So following on from the previous video, we got to this stage here where dt equals this thing. So when you come to read this, a small change in the x direction, so a small change in the x direction, combine it with this thing, would result in a small change in the time. So let's say from here, the particle falls down to here, falls down to there. So let's say it takes, let's just say something silly like 5 seconds. And then another small change in the x direction. So another small change in the x direction. So this is like your dx here. Another small change in the x direction. Combine it with this thing here. Combine it with this thing here. Then it will result in a small change, another small change in time. Let's say it takes, I don't know, 3 seconds. Let's just say that. So from here to here, 3 seconds. And then another small change in the x direction. So another small change in the x direction, combine it with this, combine it with that, would result in another small change in time. So let's say this time it takes 2 seconds to get from here to here. So dx is moving along in this direction, but then when you combine it with this, it would result a small change in time. So if you want to know how long it takes for the particle to free fall from here to this bit here, then you will need to sum up everything. So we need to sum up all the times here. We need to sum up all the times. So we got to this stage here in the previous video. For us to find out the total time it takes for the particle to fall from here to the lowest point, we need to take the integral from 0. Well, we are moving from 0 all the way to the lowest point. But what is the lowest point in terms of the x direction? So to find out the total time, we will need to take the integral of this whole thing from x being 0 to wherever the lowest point is here. We need to figure it out. Okay, so we got to this stage in the previous video. To get the total time, we need to take the integral. So hang on. So remember the formula for the parametric equations for the cycloid is given by this. You've got to ask yourself, when will, well, we are trying to find out the lowest point. We want to try and find out the lowest point. The lowest point, where would that be in terms of the x direction? So the lowest point will be, well, you've got to ask yourself, when will y be at its highest point? So the highest point will be somewhere here. When will y be at its highest point? Well, y will be at its highest point when t equals pi. Now, when t equals pi, well, y will be at its highest point when t equals pi. But where will x be when t equals pi? So you would then put that into here and then into here. So x would be at a pi. So this somewhere here would be a pi. So going back to earlier, to find out the total time, we would need to take the integral from 0 to a pi. Okay, so we would need to do this. We would need to evaluate this from x being 0 to x being a pi. Because if you look at this here, we are moving along in the x direction. That's dx, dx, dx. We need to travel all the way across here to somewhere around here, a pi. So we need to take the integral from x equals 0 to x to a pi. So we need to evaluate this. Okay, I will continue in the next video.